Okay, this is problem 6 of the test review, the last problem. A medical researcher is testing a new drug to determine if it slows the growth of malignant tumors in rats. The average growth rate for this type of tumor in rats is 6.2 grams per week, so this is what it's been, and follows a normal distribution with a standard deviation of 3.8. So they told us it's normal. That was nice. The new drug is tested on 30 rats, and the average rate of growth from the sample is determined to be 4.9. So this is our X bar. Run a hypothesis test at the 2% level of significance. All right, so they want us to run a hypothesis test telling us alpha is 0.02. So this is my alpha level. So HO, the claim. Well, what has it been historically? Historically, the growth rate has been 6.2 grams. That's how fast the tumor has been growing. The alternative, mu, and we all also keep this part the same. So now we just need to determine, is this a less than, greater than, or not equal to? And they want to see if it slows. All right, well, slow means make it smaller or reduce. So we're going to try to reduce how fast it grows, okay? Then number 2 is defining it. So let mu equal the true population mean tumor growth rate. All right. Our conditions, we took a random sample. They told us it was normal, but regardless, we're still just going to write assume. Number 4, we're going to write our equation. Z equals X bar minus mu sigma divided by square root of n. All right. We need to identify and label all of our inputs. We don't have data. We don't have data to enter. We don't have data to enter this time. I do need to draw my graph. So my graph is going to be this. The mean is 6.2. And we got a new mean. This is the population mean. We got a sample mean, an X bar, that was 4.9. And we are shading this way. Okay. So we've already, so that's number 5. Number 6, enter the data. We don't have data to enter, so we're on to number 7. And number 7 says list the inputs. Well, our mean is 6.2. Our standard deviation, they gave us and told us it was 3.8. Our X bar was, we got a sample of 4.9. And our N, our sample size, happens to be 30. Number 8 says plug in the values. So we're going to go ahead and plug in the values and make our probability statement. So the probability that Z is less than, and we're going to take 4.9 minus the 6.2 over 3.8 for our standard deviation. That should be a 3. It's not a very, that's an awful looking 3. 3.8 divided by the square root of 30. So we're going to plug that into the calculator, and we're going to do that by going to stat, arrow over to test. Happens to be the Z test, so it's the very first one. I need to arrow over so that stats is highlighted because I'm working with statistics, not data. My mean, 6.2. Standard deviation, 3.8. X bar, 4.9. Sample size of 30. And we said we had a less than, so we need to make sure less than is highlighted. We calculate, and we get the probability that Z is less than negative 1.8737 equals 0.0304. All right. So this is our p-value right here. And they told us a level of significance of our alpha of 0.02. And if I made them the same length, 304 is definitely bigger than 200. This is greater than. And when I look at stating the decision, which is number 10, if the p-value is greater, we're going to fail to reject. So we're going to go, all right, fail to reject. This is number 10. This is our decision. All right, so we got that one good. All right, the next thing we need to do is we need to write our conclusion. So our p-value is 0.0304. We fail to reject the null. There is not sufficient evidence at alpha equal 0.02 to suggest that the true population mean tumor growth rate is, what did we say? Our alternative is less than 6.2 grams. So our p-value is 0.0304. It happens to be greater than our alpha, so we fail to reject the null. There is not sufficient evidence at alpha equal 0.02 to suggest that the true population mean tumor growth rate is less than 6.2 grams. The next thing we need to do is construct a 96% confidence interval, and I don't have enough room on this paper to do all that, so I'm going to do it on a separate sheet. The very first thing says define the parameter. We've already done that. The next thing it asks for is the conditions. We've done that. So we need to go ahead and number 3, we need to go ahead and write our formula. And our formula in this case is x bar plus or minus z star sigma divided by the square root of n. Number 4 says enter data. We don't have that. Number 5 says identify all the parts. Well, we did that previously, so I'm going to get that from above. So our standard deviation from the population is 3.8. Okay, the next thing it asked for is the X bar. Well, they told us the X bar is 4.9, and we had a sample of size 30. The next part we need to do is calculate a Z star. And they wanted to do Z star based on a 96% interval. So we're doing a 96% interval. So to do that, I need to make sure that I'm doing 1 minus 0.96 divided by 2. That's what I need to be putting in the calculator. So here we go. This is the second vars. So second vars, inverse norm, parenthesis 1 minus 0.96, close parenthesis divided by 2. Mean is 0, standard deviation of 1. And we end up getting a Z star equal to 2.0537. So Z star equals 2.0537. Always make it positive, please. Okay. Then number 7. We're going to plug in, and our plug-in is going to look like this. 4.9 plus or minus 2.0537 times standard deviation of 3.8 divided by the square root of 30. So stat test number 7 is Z interval. So scrolling down to number 7. And I'm going to go ahead and make sure stats is highlighted. I'm going to input my X bar. My X bar is 3.8. You see my standard deviation is 3.8. My X bar is 4.9, 30, and we wanted a confidence interval of 96. And let me check something real quickly. Second bar is inverse norm. Good. Stat test 7. And write down my interval, and my interval size goes from 3.4751 to 6.3249. So that's my interval. Anytime we run a confidence interval, we have to write the conclusion. So our conclusion is we are 96% confident that the true population mean tumor growth rate lies within the interval 3.4751 all the way to 6.3249. This is my lower part. This is my upper part. So I could have any rate that's no value less than this and no value greater than this is plausible. Anything between there is plausible. So as low as this and as high as this. All right. The next thing, what else does it say? It says and interpret. So we need to interpret the level. All right. So we get to interpret the level. We only have to do this is step number 9. We only have to do 10 if they ask for it and they ask us to interpret. And that just means we get to do our little brag, which is in repeated sampling, we expect that this method will capture the true population mean tumor growth rate 96% of the time. So in repeated sampling, we expect that this method will capture the true population mean tumor growth rate 96% of the time. Lastly, based on the interval, by the way, we finished the recipe at this part, but it says based on the interval, is it possible the new drug is actually causing the tumors to grow even faster? Well, initially you want to say no, because we know that we had an X bar that was 4.9, which was less. But 6.3, they were having, what was the original growth rate? The original growth rate is 6.2, and we had a growth rate as high as 6.3. So 6.3 is a plausible answer. So even though the average seems lower, it's possible that the growth rate is greater. So we're going to say because the highest value 6.3249 is greater than the original 6.2, it is possible the tumors are growing faster, right? Because remember, any value within here is possible. So it's possible that they have a 6.3 rate, which is faster than that initial 6.2 rate. So yeah, it's possible that they're growing faster. Okay. Any value in that interval is a possible value. So they may be growing a lot slower, or they may be growing a little bit faster, because we don't know where in the interval the population lies. We just know that the true population mean or the growth rate lies somewhere in that interval. But because we don't know where it is, it could be on the low end where things are growing slower, which would be a good thing, or it could be on the high end, which would mean it's growing faster, which would be a bad thing. All right, so that concludes this video.